Scientists have discovered the first ever white hole after years of speculation and research. But what are white holes? Why are astronomers interested in them? Could this be real? Stay tuned as we present the first ever white hole discovered by scientists. The idea of black holes is common knowledge to most people, and they are huge objects in deep space that devour anything that approaches them. As an alternative to the black hole, there is a white hole. Although white holes are equally terrifying, knowing how black holes form is essential for understanding them better. Let's begin here. A black hole can be any size, but there are three main types, and its mass and size determine its type. Primordial black holes are the smallest. They explain that this type of black hole has the mass of a large mountain, but is as small as an atom. Among medium-sized black holes, stellar is the most common. They can be up to 20 times heavier than the Sun, but have a relatively small mass. It is easy to fit them into a ball with a diameter of about 10 miles. It is this massive mass concentration that causes a strong gravitational pull on other objects. Scientists estimate that the Milky Way galaxy contains dozens of stellar mass black holes. These are called supermassive black holes. Together, they would fit into a ball about the size of our solar system, which is more than 1 million suns. Also, it is believed that the center of every big galaxy contains a supermassive black hole. Supermassive black holes are found at the centers of the Milky Way galaxy, called Sagittarius A. They're so massive they fit inside spheres about the size of our sun. But how do they form? In the early universe, black holes were thought to be formed soon after the Big Bang. Stars with massive centers collapse inward, forming stellar black holes. As a result of this collapse, the star becomes a supernova and explodes into space. Scientists believe black holes may have formed simultaneously with the galaxies they are in. A supermassive black hole size is determined by the mass and size of the galaxy that it is in. Even light can't escape a black hole due to its strong gravity. Its gravity, however, affects the stars and gases surrounding it. Scientists can determine if a star is orbiting a black hole by studying its motion as it orbits a certain point in space. The high-energy light produced by a black hole and a star when they are orbiting close together can be observed by scientific instruments. A black hole's gravity can be so strong that it pulls off a star's outer gases, forming an accretion disk around itself. In the accretion disk, the gas heats to extremely high temperatures and emits X-ray light in all directions as it spirals into the black hole. Astronomers use NASA telescopes to measure X-ray light to understand black hole properties. Can our sun ever become a black hole? Although the sun is not saved from collapsing into a black hole, that does not mean it is safe from death. In billions of years, the sun will become a red giant. Eventually, it will burn up all its fuel and become a glowing ring of gas called a planetary nebula. A cooling white dwarf star is all that will remain of our sun. But this will be a long time from now, so worrying about this makes no sense. In this sense, white holes are relevant, which is the exact opposite of black holes. It is a black hole viewed backward in time. If any material reaches the event horizon in a black hole, it can't escape the intense gravitational pull. White holes are regions where space-time flows inevitably outward. There is said to be a radius around its event horizon that prevents all matter, including light, from entering. It is believed that the white hole emits a light at a level equivalent to a black hole. The sheer force of gamma rays would destroy any foolish crew that attempted to enter a white hole. But imagine if the ship were strong enough to handle that much energy. Further, the space-time surrounding the white hole is structured in a way the closer you get to it, the higher the acceleration. It would be useless to try to get inside a white hole because it would require a vast amount of energy. Due to the mathematical fascinations with black holes, the theory of white holes was first discovered. And in 1905, Einstein realized that non-accelerating observers do not experience time differently from accelerating observers. It is independent of motion whether they are moving at a constant pace or not. In his theory of general relativity, Einstein proposed that mass, rather than being a physical force, is a distortion of time and space. In empty spacetime, or an area completely void of all matter, Karl Schwarzschild would use Einstein's field equations and solve them to find the equation of mass. In simple terms, it represents the equation of a black hole that does not have a charge or a function of change. Unlike an internal black hole, this black hole has always existed and does not change in size. The future of all events is infinitely far away at or around the event horizon. So to an outside observer, these events do not exist. Space and time become one at an idealized black hole, as shown by the short shield metric. In that case, the singularity of a black hole would be at some future point in time, rather than a place. A black hole reversing time gives us the appearance of a dying star, but an eternal black hole reversing time gives us a white hole. White holes are not accepted by all scientists, thereby making their recent discovery all the more significant. So why are some scientists skeptical? The fact that white holes obey general relativity and are mathematically sound does not mean they can be used. Hence, some scientists call white holes an impossible possibility, which means even if they can't be excluded completely, there is no way to see one with telescopes. They believe this phenomenon violates the second law of thermodynamics, which dictates that entropy in the universe always stays the same or increases. Chaos, as well as entropy, is often described as the increase and the number of states that particles can occupy within a certain system. In the case of a house that was razed to rubble, the possibility of building other structures, such as sheds, bookshelves, and mounds, is increased by the entropy of the rubble. A house, however, consists of just one type of particle. While the overall entropy of the universe is increasing, small local decreases in entropy are possible. The black hole does this because it takes the matter with low entropy, such as planets, and disperses it over a large area over time, further increasing the chaos of the space. White holes that eject matter conflict with this law since it decreases entropy. This is the reason that physicists argue that time cannot be reversed. Nevertheless, this does not prove white holes don't exist. According to theoretical physicist Carlo Rovelli, black holes are incapable of evaporating or shrinking because of the constraints of space-time. In that case, a black hole would undergo a quantum bounce or pressure outward and would then transform into a white hole. As a consequence, black holes turn into white holes almost instantly. Nevertheless, to outsiders, a black hole persists for billions of years due to gravity's dilation of time. A black hole that was formed during the universe's early days could be ready to explode as cosmic rays or another form of radiation, just as we witnessed in any other moment of history. A gamma-ray burst, known as the GRB 060614, was detected by NASA's SWIFT satellite in 2006 in an extremely strange region of the sky. The type of bursts usually fall into two categories, which are the short and long bursts, and they are typically associated with supernovae. The GRB 060614, however, did neither of these things, and it lasted for 102 seconds, but it was not closely associated with any star explosion. By comparison, most gamma-ray bursts last between 2 and 30 seconds. The galaxy in which GRB occurred was extremely rare for stars to be capable of undergoing explosions or long bursts. Astronomers and astrophysicists believe this gamma-ray burst emerged out of nowhere and collapsed on itself almost immediately. Some years later, however, scientists proposed a theory that they may have been a white hole. What led them to this conclusion? Because of what GRB 060614 describes precisely. So what would a white hole look like? Usually from a spot too small to be seen, a great fountain of matter and energy that vanishes soon after taking form. Its strength lies in the fact that there is no other explanation for what happened in the current scientific models. So what can you say about this? Let us know in the comments below. Thanks for watching. If you would like to receive updates on Elon Musk and his companies, make sure you click the subscribe and bell button.